Okay, recap. Marcus is leaving. We love Marcus. He's going to the Playwright team. He's going to do cool things there. Uche is the new Marcus, and we're really excited to have Marcus on the team. We shipped our 0.4.1 release, our 1008 release. We have a lot of cool new stuff there. Most of the items were demoed in the last call. Now the other items, expanded hover support. You can add this @description decorator to every keyword. So modules, resources, variables, outputs, and we will show those in context where it makes sense. So right now we show them on hover. There's an ask to get those shown in the completions list as well. So we will kind of do what is expected there, which will just make authoring modules easier. You'll have more context where you need it. You can disable Linter Rules with the light bulb. So instead of having to go into Bicep config or create it and author it and get it all right, you can just in a couple clicks get that disabled, which is nice. And we have some more capabilities for using inline syntax to disable a given rule just for that file. You can run the build command in a few more places in the context menu. You can just right-click build, which is nice. We have another linter rule, and there's a bunch more linter rules coming. So we're trying to get TTK parity basically in Bicep, and then there's a whole nother list of rules that we want to go and implement. And then the last one, and this is not even it, there's more features that we couldn't list here. Just like you can create a resource group and use that as a scope for a module, and I believe you can do this for subscriptions as well. You can now use the management group as a symbolic name. So if you're doing modules between management groups and you're creating management groups, you can use the actual symbol, the resource symbol or the symbolic name as your scope value in those modules, which is just a nice little convenience. Can we go to the next slide, Stephanie? Or do I have control? Okay. Future releases. So trying to clarify the timeline a little bit. The things got pushed out as things do. So we released obviously the private registry before the public registry. And the reason why we didn't call that 0.5 is because we've communicated pretty broadly that the public registry is going to come in 0.5. So we're holding 0.5 for the public registry, which we're getting started on now. So that's us pushing Bicep modules into MCR instead of an ACR instance, and making that publicly available so we can publish known good modules. And we're working with our Microsoft field team to get that kind of jump started and seeded, but we'll take PRs for those things and all the kinds of things that you would expect for something like that. So we're pretty excited about the public registry and the scenarios that it'll open up. For 1.0, we've talked about this before. We're thinking February-ish now for 1.0. Strict breaking change policy and shipping type updates separate from core compiler updates are still kind of the two top line things that we're focused on. But then we've also talked about Bicep extensibility. We're chipping away at extensibility and we're making good progress. It's looking like Kubernetes will be the first one to light up. It's just a little bit more straightforward than AED, which has some extra complications. AED hopefully in March is what we're tentatively thinking, but AED is a beast, just to be totally transparent, and it's a little more complicated, and I don't know if it's going to make March, but we're doing our best. And then there was also a question in the community call issue thread about passing resources between modules. That's another one that we really think needs to be done before 1.0. It's a pretty fundamental change. We want to do some breaking changes associated with that since we'll have these extra capabilities. So hoping that all gets done for 1.0 in February. If you can, do the date math here, we'll probably ship 1.0 before AED comes out, but we'll see kind of how that plays out as we get closer. Can we go to the next slide, Stephanie?
Yep. All right, so this is our pass to the Xbox team. If you guys would like to hop on and share your screen, that'd be great.
Okay, I'm gonna take over real quick.
Okay. Cool.
Can you guys see slides?
Yep, we can see you. I think your mic is a little quiet if you want to move closer to it.
Oh, okay. Is that better?
That's better. Yes.
Okay. Alan, do you want to go ahead and start?
Yep, I'll start. So I'm Alan Andrews. I work in the Xbox customer experiences team. Just a little bit of history on myself. I've worked at Microsoft for about years. I started out working in SQL Server and then eventually made it over to Xbox, working in the Xbox Insider Services. As of today, I'm working on the services side of Xbox support.
I'm Chad Stewart. I'm also a developer with the Xbox Customer Experiences team. I've been at Microsoft for about 7 years now, and I have mostly worked on the Xbox Insider Experiences and Xbox Feedback Services. Right now, I'm doing a lot of console UX work for experiences like subscriptions on console or order history, things of that nature. So we're going to talk about kind of how Xbox has been using Bicep, or at least kind of in our suite of services. We started moving some of our services to ARM back in early 2020, I think. And we have only recently as late spring 2021, so maybe spring of this year, did we really start moving a lot of our services over to Bicep. One of the big pushes for this was due to some compliance stuff that I'll talk about later. But because of the way Bicep kind of allows us to share modules, it really allowed us to scale out to a lot of our services. The services that the customer experiences team, CXT, owns, they really fall into 3 large suites of services. I'm doing a lot of hand waving here. There's a lot of other stuff that's kind of being bundled into these services. But first, we've got the Xbox feedback services. This is the set of services that is responsible for collecting, triaging, routing all diagnostic problem report data that is coming across all Xbox experiences. So this is bug reports from console, from mobile, from web experiences, anything where a user is kind of like interfacing with Xbox and they have some kind of problem or like issue they want to give us feedback for. That stuff all gets uploaded into XFS. As part of that pipeline of processing, we will basically tear apart that diagnostic bundle. We'll try to decide, is this a bug? Is this a duplicate? Do we need to, whose issue is this? And then we'll create work items in Azure DevOps, which kind of get routed to the appropriate Xbox team to kind of like help with that issue. A lot of the telemetry and kind of the like downstream stuff that comes out of those services like fall into health signals for the Xbox services all up. So a lot of times when something goes wrong, the first place we see that is the feedback services because, you know, sign in isn't working. So all of a sudden people are filing bugs on sign in, like I can't sign into my Xbox. Alan?
Yep. So I'll talk about the Xbox Insider Services a bit. So the Xbox Insider Services is really a group of services that power an app called the Xbox Insider Hub, which is an app that you can download on console or on PC. What it allows you to do is you can get early access to game betas or to the Xbox OS update, which we call previews. So you can sign up and say, hey, I want to try some of the latest features on Xbox, and then we'll get you, signed up in the correct preview, and you can download the update and start playing with it. The app also allows people to give feedback, like, did you like it? Did you not like it? What would you improve about it? And that feedback we will collect and give to the appropriate team to hopefully improve the product. The last thing on the list here, Xbox Support Services, is really an umbrella term for various services around Xbox support. So if you've ever been to support.xbox.com, a lot of the stuff on that page is powered by the support services, such as the ability to search for like what issue you're looking for, getting notifications about various things about your account, like if your credit card's about to expire, like you have Xbox Live auto update, as well as you can also do automated refunds. So if you buy a game, you didn't like it, you want a refund, it'll go through our automated process where as long as you haven't played it for a very long time, we'll just do a refund. You don't have to talk to customer support. Another thing that Xbox Support Services also provides services for is another app called the Xbox Assist app, which is just an app that runs on the console that you can also get help and get the same notifications that you can from support.xbox.com.
So talking about why we're using Bicep. So first and foremost, Bicep has all the benefits of ARM, which of course just means you're templatizing your resource management. So like your Azure resources get kind of bundled together. Typically for us, when we are deploying any given service, we're not deploying just like one web app. It's typically like a web app plus a key vault policy plus a managed identity plus some other resources, right? There's kind of like these patterns for how we deploy like a web app versus an Azure function or things of that nature. And so kind of being able to, all the benefits of ARM are something we need when we're scaling out to all these services. Second kind of point is that Bicep has a pretty low barrier to entry. For those who are familiar with working at ARM, sometimes just an ARM file can be hard to look at. Big JSON blob can be hard for people who are not familiar with Azure resources or Azure in general to kind of pick up. But we found that Bicep is much more intuitive. It's basically just like, it's much more code-like in that nature. So typically when we've got people who aren't familiar with Azure resources in general, they have a much easier time kind of broaching the space with Bicep rather than ARM. We've also found it's really easy to help them kind of like visualize relationships between services, because like we said, when we're deploying certain things, we're bundling a lot of stuff together, and all of those resources talk to each other in different ways, like you're grabbing a key or you're setting a resource policy or like you're passing a setting here or there. It really helps people who are unfamiliar with services to be able to kind of look at how we are setting up the Azure resources kind of quickly from the Bicep level view to kind of understand like things how things are connecting. And then lastly, of course, the modularization of Bicep, being able to kind of like break out Bicep files as a like module or like a submodule that just encapsulates a common pattern or something that we're doing is really beneficial. Like I said, in the last 6 months is really when we have really heavily started switching over to Bicep, and that was largely driven by the fact that we have some compliance work where basically every service that we own, we want a specific monitoring agent that's collecting certain telemetry, running like a security pack. We want that deployed on all of our services. And the easiest way and we do that with ARM or with Bicep to kind of deploy that agent. And Bicep, it really behooved us to kind of just modularize that so that we could kind of replicate it across, different services, different repositories. I think in total, we've got some near 30 to 50 services and maybe like 10 different repositories. So without kind of being able to break things into those modules, we would have had like a lot of replication just in a lot of places. Plus, it just makes common patterns easier, as I said earlier. Here, this is kind of going over one of the common patterns that we use for like web API. So just your standard HTTP traffic service. Like I said, we're always bundling multiple resources together to kind of represent an abstract service in our regard. So looking at this example here, what we see is at the top, you've got us creating a managed identity, which that service will run under. There's a key vault policy we'll set up where that managed identity will kind of have access to that key vault to be able to get secrets. We've got app insights for logging. And then down here at the bottom, you can see we're doing regional app deploys and then putting it all behind an Azure front door. That's blown up here a little bit. You can see this is actually getting snipped from one of the apps in the Xbox feedback services. This is our basically shared base app, which sets up a lot of common things across all of those apps. And you can see we're basically doing that regional deploy and then funneling the like site host or basically the URL for those into our front door to kind of wrap it with everything. Here is the visualization for that. So if you're not familiar, the Visual Studio Code extension has like a little button at the top right, which will allow you to visualize your Bicep deployments. You can see this is very similar to the Bicep file we were just looking at. You can see we've got our key vault policy set up here, which has been authorized, or rather the MSI is authorized to that key vault. There's our app insights here. And what you can see here, each one of these rectangles represents one of the submodules, like Bicep, like a sub template that we're calling. You can see here we're doing for each of our regional deployments, we're creating this box, and then inside you can see this kind of little bit of a monster, but this is setting up that basically it's our compliant app, the one that's running that monitoring agent. You can see we've got a bunch of configs we're setting up here, a basic scale, like so we've got our two apps, like the production slot, staging slot, and then the app itself is running on a service plan that has some auto scale settings. And this entire thing is basically repeated per app we have. Like pretty much all of our HTTP traffic apps have a similar setup. Some might have slight differences in their scale settings or kind of how they behave. But for the most part, this template is what we use for everything. And that's why it's really beneficial for us to kind of be able to repeat like shared modules. Another example of a common pattern we're using, this is just showing a Azure function example. You can see this snippet is from 3 separate Azure functions that we deploy, all part of the XFS kind of space. You can see they've all got different app settings, like they're totally different apps, totally different responsibilities, but they all share this function base module, right? So this is making sure that all of those like shared things are common, like the monitoring agent we want and everything is set up uniform, even across multiple services, across multiple repositories. And then on this last one, you can even see this ingestion function here, XFS ingestion. It has some special requirements where it needs to scale a little bit harder than other ones for kind of reasons. But there's you can see we're attaching that auto scale setting down here. This again is the visualization of that service. So you can see kind of that same thing as when we were looking at the web API. There's this Geneva function app, which is getting created. Inside of here, we've got the kind of that shared common template that's being used that sets up our monitoring agent, sets up our apps or whatever. Here, because this is a function, we're also setting up a storage account. But I think you get the idea here.
So I'll talk a little bit about these next couple of interesting stuffs that we snipped. These are from projects that I recently worked on. So this first one is pretty much an example of just plugging in Geneva, just like Chad showed. The one on the right, though, is one where we needed to grant permissions to like one of our blob storages. So this was kind of a neat way. Now, granted, this is stuff that you could already do in ARM templates. It's just a lot more stuff you have to write in order to make it happen. And dealing with that copy index stuff. But anyways, it's just super intuitive that you can just basically create these complex objects in an array, and then you can just loop through them and then just iterate on them as far as what you want to create. Next slide. And then over here, this was another problem that we had that probably is solvable in ARM templates, but we couldn't figure it out until we moved to Bicep. So when we're creating these staging slots and production slots for like an ASP.NET Core web app or an Azure function, oftentimes we'll have a group of app settings that a majority of them are the same, but there will be slot specific things we want to change. So in the past, what we would have to do is we basically create our app settings JSON structure, and we basically duplicate the entire thing and then just change the 1 or 2 things that are different. In this case, we learned about the union operator, and now we can just basically break these parts down. So where we have our common stuff, the base settings, then we have our prod slot settings versus our staging slot settings, and then we can just kind of combine them together. It made it a lot easier to deal with. Next slide. And then this one's not as pretty as Chad's drawing because I'm not as good at the visuals, but this is just basically the outline of a blob trigger function app that I was working on. So in this case, there's a lot of containers that act as input containers to drive the process. There's also another like a storage policy that we have in here because we're trying to comply with the GDPR. So we want to make sure that the data that comes in for this particular function app gets deleted after 30 days. So we just don't have to deal with like the compliance on making sure we delete it if someone requests all their data be deleted. And then down at the bottom, you'll see the little reusable part, the Geneva configs part that again, what Chad said, helping us stay with compliance on all of our function apps is pretty straightforward.
So next, I'll talk about how we're actually doing these deployments kind of like in the live sites and stuff. So pretty much all of our deployments of our Azure services are managed completely through Azure DevOps pipelines. We typically follow the patterns that I'm going to outline here. Usually what we have first is there's a gated build that will run on PRs. So as someone's creating a pull request, we're doing code reviews, people are doing feedback, signing off, whatever. As that gets checked in, we'll move to the second step here where on check-in, a release build will run. This is a build, the gated build, by the way, is of course like running tests, things of that nature, making sure we're safe to check in. On check-in, we get a release build. This is basically a candidate for release, and we will do a continued integration build into our integration environment. So the release build gets checked in 2, and then 3, we start some kind of CI pipeline that will start deploying services. You can kind of see that over here in this example, this is an example of one of our kind of like reduced services. But you can see up here at the top when an ADO release build is dropped, so available, we will trigger our int environment. This is really just a dummy stage, which kind of triggers these others. And then we kind of go into what we'll do next. So after that int deployment has gone out and been validated through whatever means, typically we have a engineer, usually it's the on-call engineer, whoever's kind of managing the services that week, they'll do a manual push where basically they come down here, trigger this guy, and we'll start our production deployment. For when we're looking at like an individual like Azure app and how we're deploying it, typically it follows this pattern where first we'll deploy the Bicep. So for any Azure app service or whatever, or Azure function, we'll deploy the Bicep, make sure the resources look good. Second, we'll deploy to some staging slot. Basically, every single app we have, we usually add a staging slot just for testing and validation reasons. Third, we will run tests against that staging slot. These can be very varied. Sometimes they'll be really simple. Sometimes they'll be long end-to-end kind of functional tests. It really depends on the service, but we tend to follow this pattern. And then lastly, assuming that those tests have passed, we'll basically do a swap, which will swap our production and our staging slots. And then that's kind of how our services go live. Really, Bicep has been kind of beneficial, and like ARM in general too, but just to make sure that like as we are progressing through these stages of deployment, we guarantee that the resources are set up in the way that we need for our services to kind of run. We definitely had problems in the past where somebody might, you're modifying the service, you add a new setting, and you're like, oh, I go to Azure portal and I add that new setting manually. You deploy your service, it's fine that first time, but the next time someone deploys, because they kind of forget that they add this setting and we're doing the staging swaps, that setting's missing now, things break. Bicep is really kind of our guide rails around that, making sure that each time we deploy to Azure, we guarantee that the resources are set up the way we need to make sure that the services will run.
And I'll talk about some of the pain points that we ran into with kind of adopting Azure Bicep. So the first one is really around naming child resources, and this is kind of like it's probably a bug that we need to report. But for a lot of child resources, such as like slot names or slot configs, you have to give like the name of the primary resource and then / and then the name of your child resource. We noticed that in most cases, just following that pattern seems to work. We noticed that there are some other resources where when we try to follow that pattern, we'll get like this really vague validation error that says we don't have enough name for our sections or segments. And we would have to go online and try to figure out what is we're doing wrong. And we found that there's this any function that you can just put there that kind of, I guess, bypasses whatever checking Bicep's doing to get us past it. So it was just kind of a case where there's just, like I said, there's probably a bug that we need to file to probably get that fixed. But it was still kind of a little awkward trying to look up, what problem we were running into. The second one, validation error messages are sometimes vague, is kind of alluding to what I just mentioned with before. Sometimes when you hit one of these validation errors, it's not really apparent. Like sometimes it'll tell you specifically the spot you need to look for, but it's just not really clear what you're doing wrong. So more often than not, we can take the exact error message, go online, search for it, and we'll find someone else who hit the same problem and be able to figure out what we're doing wrong. The third one, which sounds like it's probably no longer a problem, we really needed a solution for like a NuGet-like solution for sharing our common modules. So like Chad has kind of alluded to, we have these common modules that we needed to have running on all of our services that are in various Git repos. And at the time, I mean, right now what we're doing is we're just using Git submodules to share, it works, but it's slightly awkward to set up. But if we had like some sort of a NuGet-like solution, which it sounds like it's here now, at least in the private one, we would prefer using that instead. So with that said, is there any questions?
There are some questions in the chat. I can read them out to you.
Okay.
Okay, I think Whit had the first question. Curious how the Xbox team handles any sort of multi-tenant resource bundles in Bicep. Do you have one master template that you pipeline the different names and values into?
So I guess right now we only have, and I don't know exactly how much we can share about like how the actual where we deploy to, but for the most part we just have a single tenant that we're deploying to. So it's not a problem that has come up. The closest thing that's come up is that we would have a deployment where we would deploy to our subscription and resource group, but then we need to like add permissions to a key vault that happens to reside in a different subscription. And I believe, I haven't worked on it directly, but there was another engineer that worked on it, and I believe the solution he came up with was he had to create a separate submodule where he could basically change the scope as to where we're changing this. And that's kind of the pattern that we found that worked in that case. I don't know if that would work on a multi-tenant because, like I said, we really only have one tenant that we're working with. But yeah, not sure if I answered the question.
I think it unfortunately
that's very helpful.
Cool.
Yep.
And then you had another question about using Service Fabric. Alan, Chad, are you guys using Service Fabric? I might have missed that.
We're not using Service Fabric.
Okay.
Never mind.
That one. People now know about Geneva as a thing, which is our internal monitoring tool. I don't think that's a big secret. But that
it isn't now.
Yeah. The other one, there was a question around testing. Yeah, so Kevin was asking, would love to learn more about the testing involved to approve a testing slot build to be moved to the production slot.
So I can talk a little bit about this. So actually, one of the services we worked on recently was basically Xbox subscriptions, where you can change these subscriptions, your Xbox Live subscription, your Game Pass subscription on the console directly. There was a solution that was in place where it wasn't all that great, and then we kind of redid it as far as the service goes. And this was one of the ones that we used for Bicep as well, or this new testing strategy as well. What we did was we have an Azure front door that actually can route between our integration versus our prod environments. And we basically use headers that can kind of dictate, all right, if this particular header shows up and it has this value, we're going to forward it down. We're going to send it to the group of web apps that are the integration environment or the production environment. And then we also make sure that our staging environment is addressable as well. So what we do is we'll deploy the new code to the staging slot. Then we'll run a test that, in this particular case, this is an HTTP test. We'll run a test where we'll set the headers to particular values, making sure that in Azure Front Door, it routes it to the staging location. And we also make sure that if this route is taken, we will set the return headers coming back to indicate like where it went. Did it actually go to the staging slot like you thought it was going to? Did it actually go to the region you thought it was going to go to? So we will run a test where we just try to hit this endpoint, setting these particular headers. Once the response comes back, we'll check the response headers to make sure that they match, making sure that we went to the location we thought we were going to, in addition to checking, the payload, making sure the payload's exactly what we expect it to. And then we pass. The test is really, it's just an MS test that runs within ADO. Does that answer your question? So we make sure that works, and then provided the testing task runs, then we'll do the slot swap, and we'll actually run the same test again on the production slot, just to make sure that things didn't break during the swap.
Cool. Kevin, did that cover everything for you?
Yeah, I believe so. So there's a standard just unit tests that you're just running, XUnit or whatever.
Right. So that's for deployment. There's also another test that we have, and this one doesn't run as an MS test, but we have this thing called like a heartbeat test, where there are some endpoints that just don't get a whole lot of traffic. That we sometimes, if we don't get traffic for a while, we can't set up monitors to look at the telemetry to make sure that it's still up and running. So we will generate that traffic periodically with an Azure function, where the Azure function will just wake up like every minute and then just hit the endpoint, and it'll emit telemetry that will tell us if it's passing or not. And then we will set up some sort of for us, it's called a monitor in the Geneva ecosystem, but I believe in App Insights, it's just an App Insights alert. You can basically say, hey, I expect this metric to show up with this particular value. And if it ever stops showing up, then we'll generate an alert so that we can alert the on-call saying, hey, this once a minute test, it just stopped working all of a sudden, the site might be down. So that's kind of like a second thing that we do, but that doesn't block the deployment. That's just more of a making sure things are still running while production is live.
No, that's very cool. Yeah, just trying to see as what kind of tests you're running to determine that the stage slot deployment has met the criteria that can get pushed to production or the next stage up. So that's very cool. Awesome. Thanks, Alan.
Yep.
Cool. Any other questions before we move on? All right. Alan, Chad, it was really awesome to see what Bicep looks like in the real world for you guys, particularly how you tie it together with pipelines, how you test it, how you roll it out. It's easy to talk about things in theory, but it's always great to get like a boots in the ground look of what's going on. So thank you.
Yeah, no problem. Thank you.
Thank you guys for coming.
Yeah, thank you.
All right, the next part of, we're talking about creating linter rules. Stephen, I'm not sure if you wanted to share your screen for this.
Yeah, I would like to.
Okay, great.
Okay. Okay, I can assume you can see my screen.
Yeah, can you zoom in 1 or 2 clicks, Stephen?
Better?
Perfect. Yep.
Okay. Yeah, so I'm Stephen Weatherford. I come from the developer vision side of this. We've got at the moment 2 engineers, including me, that are helping out with Bicep, but we also have other work on the other side. But I've been working on dev tools for Azure and for Visual Studio, etc. I've been here about 27 years. I currently own the ARM tools, ARM template tools extension in VS Code, if you're familiar with that, and the tools that we have in VS as well. Excuse me. So I'm just going to give a quick overview of what we're doing with the linter rules right now, where we are, and if people are interested in trying to add some of their own to the core product. So our status is we're not ready to try to open it up to extensibility yet. That's definitely our plan. But at the moment, we started with some core rules, and we're trying to build those up. At the moment, we have 2 of us that are filling out equivalents to the ARM TTK rules. And so hoping to get a better idea of how these work, how they affect performance, what the design needs to be before we actually go to that. So easiest way right now, if you are interested in seeing a new rule in Bicep, is just to enter an issue. There's a label you can follow, but either way, enter it there. If you are very interested in actually contributing a rule, we are certainly open to looking at those. Please do a proposal first. Let us know what it would do, why it makes sense as a general sense rule. Get our buy off and then dig in. And there are what, about 8 or so currently. We're adding more, so you can see examples there. And I'm going to show a couple quick ones. So this one, secure parameter default rule, simply says that, here, says that if you have a secure parameter, that you should not have a hard-coded value for it. And of course, if necessary, these can be turned off, but in general, that's the best practice. This comes from a TTK rule. So it's fairly easy to implement. Actually, a lot of these are fairly simple when you get down to it. So this is the rule here. We have a simple base. Again, the design is not very, it's a fairly simple design at the moment. We'll add to it as we need to. We've got the code for it, the description, documentation, and so forth. And then on the analyze, we are given a model. This is the semantic model. You can also get the syntax from that syntax tree. So right here, I'm looking through all the parameter definitions or declarations, making sure it's actually a parameter, checking for default values, and oh, here it is. And if it's secure, then if it is, we're just actually finding out the value. So in this case, we've got a string. If it is an empty string, then we're fine. If it's an object syntax and there's nothing in it, it's also fine. Otherwise, we want to check if it's a call to new GUID so that it would be actually unique. And that's done down here. For that, we have a syntax visitor, which in this case is very simple. On any function call, we just check for the name. This one actually has a known to do. We need to check for the AZ namespace as well. There's an issue for that. So it's fairly simple. One of the guidelines is to try to avoid using syntax visitors to visit the entire tree. So narrow it down if you can, because the rules do get run often. At the moment, they're done on every key press. That will change, and we're also going to be doing some more work to verify exactly what the performance is and make sure we're not causing any problems there. So that's this simple one. To show one that actually does look at the syntax of the entire tree. Sometimes it's necessary. This is one. This is the one I wanted. This simply says if you've got a single string and a single interpolation in it, then we should get rid of the string. And this, we actually see this a lot from people that aren't used to Bicep, because this is a frequent, this is how you'd have to do it in ARM templates. So I'm trying to help people out to make it easier. So just point that out. So the code for this, in this case, it is a syntax visitor that goes through the entire tree. And it essentially looks for all string possibilities. Is that if it's interpolated, sorry, then it's only has to have, and it has one element, and the element inside is variable access, then we'll catch the rule. And we can actually add a code fix as well in this one. So that's a simple rule that visits the entire tree. Here's one. There was a question in GitHub specifically about visiting resources, which we don't have in the current version, but we're actually working on several. So they'll be there soon. You can use them as examples. So this one, checks that if you have a custom machine extension, and you have a command to execute that possibly contains a secret. So that would include things like use of a secure parameter. That's really annoying. Or running things like list keys those are the things we look for. And if it's under settings, then that's a violation, and the suggestion is that it's moved to protected settings. So that's what this rule is looking for. And so in this case, rather than doing a syntax tree, we already have access to the semantic model. So we're going to loop through each of the resources individually. That'll grab nested resources as well. Whenever possible, we should exit out as quickly as possible. So for instance, checking the actual types that we're looking for so that we're spending as little time on most resources as possible. So this one checks that. Then we simply do some checks for the properties, the top level properties. We check that it has a type property under that. And that custom script, right. And we are looking for types containing custom script. Finally, we check further under settings and command to execute. And if it's there under settings, then we will check to see if it contains a secret by passing in that syntax to a specific visitor that we'll probably be reusing in other rules. And so that's it. So it's fairly straightforward. If you're going to write these, there's a lot of code exposure that you'll have to figure out, but we've got examples. We would be more than happy to help anybody that's interested. So a couple more tips. My suggestion is to write the unit tests first, get the actual false and positive test cases down. That'll help us, and it'll help the documentation. It'll help make sure you're getting all the edge cases, because again, these will be run whenever the user is typing, so the code state could be anything, so they have to be robust enough for that. And I'll be producing at least some short guidelines on what else you need to do to get this working, get tests passing, and get these in. Any questions?
There were a handful of questions in the chat, but Marcin and Anthony covered them for you.
Okay. Yep, I'm seeing those.
Any other questions before we move on? Okay. Thank you for walking us through that, Stephen. Really appreciate it.
Sure. Looking forward to seeing all the new contributions.
Cool.
We're just about at time. If there are any last minute questions to come in, we'll stay a little bit longer. But yeah, thank you guys all for coming today. Thank you, Xbox team. It was so great to hear from you and all of the people from Australia who are finally able to make it. Thanks for showing up.
Thanks, everyone.